You know, it's funny. If you take an AI course at a university, you'll probably spend about 90% of your time on these really complex algorithms and neural networks. But then you get a job in the real world and you discover a pretty surprising truth.
And yeah, that's the number, just 10%. That's roughly how much of the real-world day-to-day work is actually about the algorithm. It's a way smaller piece of the puzzle than you think.
So, okay, if the flashy AI part isn't the main event, then what is? Well, that's what we're diving into today. We're talking about the absolute backbone of artificial intelligence, data architecture and data pipelines. It's the stuff that doesn't make the headlines, but believe me, it's what makes everything actually work.
To really get our heads around this, we're going to use one core analogy. I want you to think of an AI model as this incredible, multi-million-dollar Formula One engine. I mean, it's a masterpiece of engineering. But if you take that perfect engine and you pump cheap, dirty, low-grade fuel into it, well, that F1 car is going absolutely nowhere.
And this leads us straight to a fundamental concept that completely debunks the myth of the all-powerful algorithm. It's called garbage in, garbage out.
You see, the popular image of AI is something like a magical, glowing brain that just thinks. But the reality for the engineers who actually build this stuff, it's much, much closer to designing a massive, incredibly complex plumbing system. And the whole point of that system is to manage the flow of just one thing, data.
There's this legendary saying in computer science, garbage in, garbage out, or GIGO for short. See, an AI algorithm is really just a very sophisticated math equation. It has absolutely zero common sense. So if you feed it a million photos of dogs, but oops, half of those are actually pictures of blueberry muffins that just kind of look like chihuahuas, guess what? The AI will confidently learn that a blueberry muffin is a type of dog.
So the multi-million-dollar question is, how do you stop that from happening? How do you prevent garbage from ever even reaching the model? Well, the data has to travel through this highly controlled, highly filtered system. And that system has a name. It's called a data pipeline.
All right, so let's actually take a little journey through this pipeline and see how that raw AI fuel gets refined. This journey really has three critical stages. First up, we have to gather all the raw material. That's ingestion. Then comes the real heavy lifting, which is cleaning. And finally, we have to translate everything so the machine can understand it, and that's called formatting. Okay, let's start with stage one, ingestion. Let's imagine we want to build an AI that can predict housing prices. First thing we need is data, right? A ton of it. So we'd probably write a little script to scrape a bunch of real estate websites. You can think of it like a digital vacuum cleaner, just sucking up all the text, all the images, all the tables it can find all across the web. But here's the big problem. The real world is incredibly messy. That digital vacuum cleaner just sucked up prices in dollars, euros, and yen all jumbled together. It grabbed descriptions in English and Spanish, a bunch of broken image links, maybe some website ads, and a whole lot of just missing information. This raw data, it is basically toxic to an AI model. It has to be purified.
And that brings us to the most important step of all, cleaning. And I'm not exaggerating when I say this is where data engineers spend the vast, vast majority of their time. This is the real workhorse stage of the whole process.
So this cleaning pipeline basically runs a whole series of filters. For example, what do we do if a house listing is missing its square footage? That's called a null, and we have to decide how to handle it. Or what if the same house was accidentally listed twice? We've got to find that and deduplicate it. And what if someone accidentally typed that their two-bedroom apartment costs, I don't know, $50 billion? The pipeline has to be smart enough to flag that as a crazy anomaly, an outlier, and remove it so it doesn't completely destroy the math.
So, only when that data is completely scrubbed clean can we finally move to the last step, formatting. This is all about translating human concepts into the only language a computer really understands, numbers.
I mean, think about it. An algorithm can't do math with a word like townhouse. You can't multiply it or divide it. It's just a concept, not a number.
So during formatting, we transform it. We use these clever techniques, like one called one-hot encoding, to turn categories into simple binary numbers, zeros and ones. So in this case, maybe townhouse becomes the third option in a list of 4 property types. And just like that, we've made the data something a machine can actually work with. The whole end goal of this massive pipeline is to produce this perfectly clean, perfectly structured data. It gets loaded into a huge database, and only then, Is our high-grade fuel finally ready for that Formula One engine? Which brings us to our final, and honestly our most important takeaway from all of this.
Here's the big secret about the state of AI today. Anyone, and I mean anyone, can go online right now and download an incredibly powerful, pre-built AI model. The algorithms, those engines, they're becoming a commodity. A lot of them are open source and totally free.
And this is the absolute crucial point. The true competitive advantage in AI today isn't the model. It's the quality, the scale, and the clever architecture of the data that you feed into it. It always comes back to the fuel.
This really is the secret key. If you can master how data is pulled in, cleaned up, structured, and moved around, you fundamentally hold the keys to the entire AI ecosystem. That is the truly valuable skill.
So I'll leave you with this one question to think about. If the AI models themselves are becoming free and accessible to everybody, what is the real price of admission to compete in the world of artificial intelligence?